Tokens float in from edges. Lines of light connect them, some bright, most dim. Title writes itself. You've heard it 100 times. Transformers, attention, self-attention. But nobody ever shows you what it actually is. Today we fix that. A sentence: the animal didn't cross the street because it was too tired. Words appear one by one. It glows with a question mark. Before attention, AI read text the way a conveyor belt moves boxes. One word, then the next, then the next. The problem: by the time you get to the end of a long sentence, you've forgotten the beginning. Here's a sentence. The animal didn't cross the street because it was too tired. What does it refer to? The animal? The street? A human knows immediately. The old AI had no idea. It had no way to look back, no way to connect distant words. That's the problem attention was designed to solve. Think about how you actually read. You don't process words one by one in isolation. Your brain constantly connects things, relates things, asks, what matters here? When you read "it was tired," your brain instantly scans back and links it to animal. That scan, that lookup, that is attention. Attention is a way for every single word in a sentence to ask, which other word should I be paying attention to right now? And then each word gets the look at all the others and decide. Here's how it works under the hood. 3 things: query, key, value. Think of it like a library search. Your query is what you're looking for. I need information about the subject of this sentence. The keys are the labels on every book in the library. Every word has one. The values are the actual content inside each book. You take your query and you compare it to every single key. The closer the match, the more you attend to that word's value. The word "it" sends out a query. Who am I? It compares against the key of animal, strong match, against the key of street, weak match. So it borrows mostly from animal's value. That's how it learns what it refers to, not from rules, from math. Let's see the actual math. Don't worry, it's simpler than it looks. Step 1. Take the query vector for a word. Multiply it by every key vector. Dot product. You get a score. High score means pay a lot of attention in here. Low score means ignore this. Step 2. Run those scores through softmax. This turns them into probabilities. All scores sum to 1, like a spotlight. It can light everything equally. Step 3. Multiply each value vector by its probability and add them all up. The result, a new vector for that word. Once that has absorbed information from the more relevant other words, every word does this simultaneously all at once. That's what makes transformers so powerful. Parallel attention at every position in every layer. But one attention head isn't enough. What if a word needs to pay attention for different reasons at the same time? Bank, for example, might attend to river for meaning, but also to the for grammar. The solution? Multi-head attention. Instead of one query key value lookup, you run 8 or 16 or more. Each head learns to notice different kinds of relationships. Head 1 might specialize in subject-verb agreement. Head 2 might try co-references like it pointing to animal. Head 3 might connect adjective to nouns. Each head sees the same input, but focuses on completely different patterns. Then all heads are concatenated and projected back into one vector. Multiple lenses, one sharp picture. This is why large language models can follow a conversation. Every time a token is generated, it can attend to everything that came before. The word being predicted right now can look at the first word of the prompt, no matter how far away it is. This is called self-attention, the sequence attending to itself. And this is what killed the whole architecture. RNNs process sequentially, they forgot. Attention processes everything in parallel. It remembers everything. A 1028 token context window, that's the model holding attention across 1028 positions simultaneously. Every token connected to every other token through math. Attention is just one component inside a transformer block. After attention, the output passes through a feed-forward network, then layer normalization, then the next block. GPT-4 has 96 of these blocks stacked on top of each other. Each block refines the representation. Each layer of attention builds on the last. By the time a token has passed through all 96 layers, it contains information from every other token, filtered, weighted, refined across 96 passes. The final vector is rich, dense, and contextual. That's what gets decoded into the next predicted word. And that's why transformers can write, code, reason, translate all at once. Attention is the engine. The transformer is the machine. So, attention is a learn lookup mechanism. Every word asks, who should I look at? And the answer is learned from the data. Query key value, dot product, softmax, weighted sum, that's it. That's the core of every large language model alive today. If you want to go deeper, the original paper is Attention is All You Need by Wasmani in 2017. 8 pages that change everything. Subscribe if you want to understand AI from inside, and in the next video I'm going to explain how those same principles power image generation. See you there.